definition of a logarithm. This is how we define it. It's a log a base a. Log of x base a is equals to y. How did this come about? We have already done exponents. And in exponents, we know that we have a base with an exponent y equal to x. To move from this notation of exponent to a log, we introduce a log to a base a to a base, a log of x equal to y. So essentially, what have we done here? What have we done here? We are taking an exponent and making it a subject of the equation. So if you see here, y is an exponent of base a. We make it a subject of the equation, and we take the log of the base, log x base a log of x with a base of a. A remains a base. Nothing changes. A is still a base. The only thing that we do, we take the exponent, we make it subject of the equation. And we are actually talking about the log of x. The log of x. Log x. So that is how you work with the log. And this topic is applicable to learners who are doing matric or grade 12. They do logs. We are going to revisit this section when we are doing exponential functions. We'll be doing logarithmic functions too. They go hand in hand. All right. So in a log form, I just want to demonstrate a log form and an exponential form. What is the difference? Is exactly what I just explained. Here we have a to the power y equals to x. On the log form, we are looking for, we are doing a log of x. So log x with a base a is equal to y. If we have 10 to the power 5, this is 100,000. How do you express 100,000 in a log form? You have log of base 10, because the base here is 10. You see? And the exponent becomes subject of the equation. And this 100,000 is the log of 100,000 that we're looking for. equal to 5. Let us do one more example. If you have 2 to the power 3, we know it is equal to 8. Now, this is the base, and we want the log of 8. The log of 8 with base 2 is equal to the exponent. I think it is clear now. Anybody can follow this. Okay? Right. The properties of logarithms. Let us state properties of logarithms. From the beginning of all my lectures, from lecture number 1, we've been talking about the properties, talking about the laws, talking about the principles. I hope you can see that these things are accumulating, and we need to keep them in our heads, because these are the tools that we are going to use in order to be able to do mathematics, to solve mathematical problems. We need these tools. This is part of our toolbox. Properties of logarithms. Just say properties of logs. Okay, so property number 1, we talk about a log of 1 to the base a equal to 0. What does this mean? Look here. We have log x base a equal to y. So here we have log 1 base a equal to 0. What is this? It means we must have a raised to the power 0 to get 1, because that is the law of one of the law of exponents. Any variable or a number raised to the power 0 is equal to 1. So here, what does this thing mean? We must raise a to the power 0 to get 1. That is how we are going to get 1. Number 2. Log of a to the power a is equal to 1. What have we done here? We raise a to the power one to get a. Number 3, these are important definitions. When you have log a to the power x, base a equal to x. Wow. See, things are changing here. What have we done here? It means we are having a to the power of x in order to get a to the power x. We have a or we raise. We raise. To speak a proper language of the exponents, we raise. We raise a to the power x, to the power x. To the power x, to get a to the power x. Number 4. We now have a, this looks totally different, exponent log x with base a. This looks interesting. What have we done here? It means log x base a is the power to which a must be raised to get x. To get x. These 4 properties, they are very important because they enable us to understand exactly the properties of the logs. We've been doing properties of real numbers, properties of this and that, properties of fractions, and those properties, they gave us a good background, a very clear background of what we need to do with respect to algebraic expressions wherever those theories are applicable. At the end of the day, you will find a mathematical problem that is just going to include everything. And when it's like that, you must not say it's complicated. You must be able to break down each and every piece and be able to see which relevant law, which relevant property, which relevant principle is applicable. That's all. These things are not really that difficult. They become difficult when you make errors by maybe mixing up the laws or interpreting the laws wrongly, or you have no understanding of the laws. Then you will find a problem. I hope that helps. A common logarithm. A common logarithm is identified by having a base of 10. So a common logarithm a common log it has a base of 10. It has a base of 10. Like any variable or like any other number, it is raised to the power 1. If it is not raised to the power 1, then we'll write maybe the power is less than 1, you're going to write a to the power half, or a to the power 2, which is a squared. But if a is to the power 1, or any number to the power 1, we do not write that one. So similarly to logs, a log x, without writing the base or specifying the base, is the same as having log x base 10, unless you change the base. When you change the base, you must specify what is the base, because that base that you're talking about, we're talking about a base of the exponent. Is the base of the exponent. This statement tells us that log x, it is equal to, is the same thing as log x base 10. Is the same thing. If you like, you can write log 10 or log x. I prefer to write log x without base 10, unless the base is different. Then it is then that I'm going to specify it. We also have natural logs. Natural logs are those logs with a base e. I don't think at high school level this is done, but nevertheless, a natural log, it has a base e. It has a base e and is denoted as ln, by ln, right? If you have ln x, this is a natural log. It is the same as having log x to the base e. What about the natural log of x? What does it mean? Well, we go back in the same way where we've been explaining, where I explained the log of something with a base in terms of exponential notation. Ln x equal to y. In an exponential form, we write it, we said it has a base, ln has got a base e. Here is the base, and to the power y. We even previously, when we were dealing with the logs on the previous slide, we said the exponent becomes the subject of the equation, so they behave the same. And the log of something so y to the power e is equals to x. If this base was not an e, it was not e, we could be having a log with a base of something in this format. So these things are the same. They almost work the same way. They behave the same. The log and the ln, the natural log, they behave the same way. Let us do the properties of natural logs. They are similar to the properties of logs. of logarithms. So properties of natural logs. One, ln 1 is equal to 0. Here we use the same reasoning as we did here on the properties of the logs. Number 2, ln e is equals to 1. Number 3, ln e to the power x is equal to x. Fourth, x to the power ln x is equal to x. We dealt with the laws of exponents. The logs also have their own law. They are laws. Laws of logs. There is a condition here which I need to state first. Let A this is crucial. Let A be a positive number with A not equal to 1. Let A be greater than 0 and B greater than 0. And C be any real number. Law number 1. This is a log of A B, a product of A and B, which is equal to log A base A plus log B base A. When you look at this, you remember when we were doing exponents, we were adding the exponents on the condition that the bases were similar. Look at the bases here. Base A, base A. So that is why there is an addition sign. Number 2. Does it look like number 2? doesn't. Number 2, we have the log of log base A, log A over B base A. Remember again, we are bringing the same thing as we did with the exponents. You'll see here, division, and we are subtracting. On the exponents, we were dividing similar bases and would take the exponent of the numerator and subtract the exponent of the denominator. We're doing the same thing here. Thirdly, we have log A to the power C base A. What does this tell us? C multiplied by log A base A. This is it. Number 4, the last one. Number 4. We have log x base A divided by log B base A. What happens here? We divide log x base A by log B base A. Here we see a change of base. This is a change of base. This one. It's a change of base. I think you get it. As I've stated that this is a short lecture, it is indeed short, but I just want to do an example, just one example of the equations for solving a log equations. We start with an exponential equal to 7, but this I will do when we are doing exponential equations. I just want to demonstrate how logs work, because after this lecture anyway, I'm going to do equations. We are going to introduce and take a log both sides. I'm taking a log. Log 7. Remember law number 3. This law. This one. You take the exponent, you multiply it to the log. Let us do that. We're going to take x plus 2 log 3 equal to log 7. And remember, when logs are written like this without any specification on the base, automatically we assume is log. The base of the log is 10. So now what do we have? We have x plus 2 equals to log 7 over log 3. Lastly, we have log 7 over log 3 subtract 2. X is approximately equal to negative 0.28. You can do your calculation, you'll see. This is just an example of how you introduce a log into an exponential equation. We're still going to do exponential equations, and we'll do them together with log equations. Alright, so we are done now. I just wanted to talk about logs. That was it, nothing else. Okay. Thank you. Please like my video, subscribe to my video, and share it with your friends.